Hi, welcome to the November Sci-Cafe. Um, Thank you for joining us. This is a virtual series that the Reserve puts on to share information about research being conducted in Apalachicola Bay in an informal and casual setting, bringing together residents and scientists to explore different topics. So our program will be about an hour in length. We'll have plenty of time for questions. And if you like, you can type your question into the box, or I can unmute you. Today we have with us Dr. Sandra Brooke with FSU, and she's going to talk to us about the research that she's been conducting in Apalachicola Bay, and Devin Resko, who's with the Fish and Wildlife FWC. So he's going to talk to us about the recent restorations that have just been completed. And without further ado, Sandra, take it away.
Thank you, Anita, and hello, everybody out there in Zoom land. So the Apalachicola Bay System Initiative was funded in 2000. We then hit COVID a year later, almost to the day, actually. And then in the fall of that same year, 2020, the Apalachicola Bay oyster fishery was closed down sort of temporarily until the authority to close it down for the next 5 years was issued by FWC in December 2020. So given that, now we struggled during COVID to get research done, but we did manage. And since then, the research through the Apalachicola Bay System Initiative, or ABSI, has ramped up, and there's a lot of it. So but I chose today to talk to you about a topic which seems to come up more often than others, and that is, how are the subtidal oyster populations doing in Apalachicola Bay? So our annual bay-wide monitoring began in December 2020, just about the same time as the closure of the fishery. So we were first looking at the bay after just as harvest was ended, right? So we decided to do our sampling a little bit differently from the way FWC does theirs, which is scuba diving. We worked with a local oysterman, and we used tong sampling, which I'm sure you're all familiar with if you live near Appalach, but if not, this is the traditional way of harvesting oysters, and they're basically a giant capture. I don't know really how to explain a teeth. And you can see the picture up there with long handles. It's extremely hard work, and it's how the oystermen have been doing this for generations. So we developed a tonging sampling method. We had 6 samples per boat. So we pulled up on a site. We took a sample from each side of the boat, bow, mid, and stern. So that's 6 samples. We took the total volume and weight of the material. We counted the number of spat, the seed, and the market. And these are little ones, medium-sized ones, and market-sized, which is over 75 millimeters or 3 inches. And then we also measured the shell height of all of the live oysters that we collected. So I'm not going to talk about rounds 1 and 2 just for the interests of time. So I'm going to jump to round 3. So this tong sampling was done every winter. And so in our round 3, which was in March 2023, we selected 227 sites. Now, the number of sites has varied from about 117 up to 227, which was our maximum. And what we were trying to do here was to identify different types of habitat. And then we did an analysis to figure out how many samples we needed in each.
Hey, Sandra?
Yes.
Can I interrupt just a second? For some reason, we're not seeing your screen.
Oh.
We were seeing it, but for some reason, it's not there.
So you're not seeing anything, or are you just not seeing my...
I'm seeing a picture of you and Devin.
Oh, well, that's no good. All right. Let me see.
Just try sharing screen again.
Yes, you have to give me permission again.
Gosh, again, that's weird.
Mm. Maybe Devin stole it when you gave it to him.
I guess. I don't know. They've made some changes in the program, so I don't know why I have to keep hitting that
Oh,
button, but it seemed to.
sharing your screen. Okay, apparently I'm
Sorry, I was
sharing.
trying to figure out if it was just me or if it was everybody.
Uh, okay, let's try this again. Can you see my screen? Can you see the presentation?
It's coming up. Yes, I can. It's just
Okay.
it
All
needs to be.
right.
There you go.
So
Perfect. Thank you.
yeah, no worries. So just a brief recap. So yes, we began in 2019, Apalachicola Bay System Initiative. I'm going to talk about the subtidal sampling. We use tongs. This is probably much more illustrative than me just gabbling. So tonging has been used by oystermen for generations in Appalach, and it's these giant pincher type contraptions with the long handles. And as I said, very hard work. And so as opposed to FWC, which uses scuba diving for their sampling, we decided to do our monitoring with in collaboration with the local oystermen. So we took samples, 6 samples around the boat, and we measured the total volume and weight of material that he pulled up, and then the number of spat, the little ones, the seed, which is the intermediate stage, and the market stage, which is over 3 inches or 75 millimeters. And then to get more sort of resolution on the size distribution of the oysters, we measured the height of every oyster that we encountered. Okay. So that bay-wide monitoring began in December 2020 as the fishery closed, and we did it every year since. So I'm going to focus on, rather than going over rounds 1 and 2, I'm going to start with round 3, which was January, March 2023. We did 227 sites. Now, as I was saying, we wanted to look at different habitat types and see whether there is any differences in the number of oysters that we found in each of those habitat types. So what we did, we split the habitat types basically into 3 types. There's limestone or lime rock, which was little pieces of limestone that 2 of the restoration efforts used. That's they are the the FDEP Restore Act, which are the green squares, and then the FWC NIFWIF leftover money, which is the yellow blob-like areas. And then there was the stuff that was restored with fossil shell. Those are the pink areas, and the yellow little squares that you can maybe see. And then there was natural reef, which is kind of a catch-all for everything else. Okay, so bear that in mind. And then we just did an analysis to make sure that we were capturing all of those areas adequately. And this is how we came up with the 227 samples. So our poor oystermen had a real workout that year. And so these are our data from the round 3 monitoring. And so what this shows, if you look at the left-hand panel, that's the western side of the bay. And the right-hand panel is the eastern side of the bay. And if you just imagine a line that goes all the way across the bay, each one of these sampling points shows you where in the bay along that line that each of our sites are. Hopefully that makes sense. And so the top panel is the number of market-sized oysters per tonglick. Now our tonglicks are about 1/2 meter squared. So that line, that horizontal line across the top panel that you can see there represents 400 bags per acre. Now, this is the amount of oysters that FWC has kind of stipulated will support a fishery. Okay, so 400 bags an acre. And as you can see, on the western side of the bay, there's only one site that seems a little anomalous that's bounced over that 400 bags an acre line. If you go to the eastern side of the bay, you see there are several sites in there that are over that line, so potentially harvestable. Okay, the panel below is the seed or the number of juveniles, and the one at the bottom there is the number of spat, the little tiny guys. And as you can see, there's more of those, a lot more in the eastern side of the bay than the western side of the bay. So the western bay is struggling, even several years after the fishery has closed. Okay. So when we look at the distribution across those different materials, you see here, again, so this is a lot of information squeezed on one graph, but if you look at the west side of the bay to start with, left-hand panel, the lime rock is the kind of yellowish color. And so it's not terribly consistent on the western side of the bay, but generally speaking, the lime rock is doing better than either the fossil shell or the natural reef. Something happened in 22, 23, where that lime rock, the number of seed just kind of dropped out. Spat, sorry. But the number of market-sized oysters now in the western side of the bay in 22, 23 on lime rock seems to be doing pretty well. Not great, but pretty well, because that's only 4 oysters per tongue-lick there. So if we go to the eastern side of the bay, you'll see that, again, the lime rock is doing consistently better across time, but a little more encouraging, if you look at the other materials, the shell and the natural reef, they're starting to creep up with the seed and the market, especially the market. So this might be a sign that some of those areas are actually starting to recover, maybe. So we have to be cautious here. So given this information, we decided to really focus for the 4th round of tonging, focus on those lime rock areas to really drill down and try and work out what is going on specifically in those areas, as they are the ones that are going to be probably targeted by the fishermen when the fishery opens again. So we wanted to work out what's going on those potential fishing grounds. So of those, there are 17 areas across the bay that have been planted with lime rock. Okay, there were, I can't remember, there were three of these were planted in 2021 and the rest were planted in 2016, so different ages. So what these, the black lines, the black squares, what they are the areas that were targeted for that restoration. So the green inside, what that represents is sonar data or mapping data that was taken using sonar that shows the actual distribution of the material inside those squares. And you can see for the most part it lines up, but the squares aren't filled by any respect, and some of them are a little kind of not sure quite what happened there. So we had 17 areas, and within that 66 sampling sites, just to make sure we got enough data. Okay. And when we go and map, this is what the sonar looks like. Now, these are sonar data taken by our research vessel for the 3 sites that were planted in 2021. And as you can kind of see, they kind of look like a plate of noodles. These rocks were blown off a barge using pressure hoses. So even though those sites look like nice little squares, within the sites you've got this kind of noodle effect. So what we did then was we used a software program to actually look at those bright areas within the squares, and those actually represent the rocks themselves. So we can figure out how much area within those squares is actually hard substrate that the oysters are using. Okay. So that's what we did. Now, again, this is a similar representation to the one I showed you before, and this is for spring 2023. No, sorry, spring 2024. I'm losing track of time here. So again, the western side of the bay is looking a bit sad. It's not reaching that 400 bags an acre. There's not many spat. There's not many seed. It's not doing well at all. Eastern side of the bay is a different story. So we're seeing quite a few spat, quite a few seed, and also quite a few of those sites that have crept over that 400 bags an acre limit, that threshold. So this is encouraging. Okay. So then what I did was we wanted to know, Okay, we know the amount of area within each of those sites. We know how many bags per acre we've got in each of those sites. So the panel shows you just a different representation really of the one before. So this shows you the number of bags of market-sized oysters per acre. Now this isn't number per tongue-lick. I just did the math and calculated number of bags of market-sized oysters per acre at each of those sample sites. And that line now represents 300 bags an acre. And this 300 bags was what FWC proposed as a threshold for supporting a limited fishery. Okay, so this is the point at which they can support a limited fishery, not a full-blown one. All right, so got to go careful here. So you can see there that there are 5 sites that actually cross that threshold. Okay, so if we go to the table, yeah, it's a lot of numbers, but the sites are listed on the left-hand side there. The acres of hard bottom is what we calculated existed within each of those sites. All right, so the ones that are over the threshold for 300 bags a limit are highlighted in orange. Okay, so with the total, or rather the average bags per acre in the next column. Okay, then what I did was I removed 300 bags from that total to get the number of harvestable bags. And what that means is that, say in the top one, you've got 453 bags per acre. All right, but the harvest will stop once you get down to 300. That gives you 153 that are actually harvestable per acre. So if you multiply that by the number of acres, that gives us 2,311 total bags that can be taken off of that one site before you reach that threshold where it's not sustainable anymore. Okay, I hope that makes sense. So I did that for all of those 3 sites, and so we got a total of 13,324 harvestable bags. Okay, so that's what we have to play with. So there we go. Oh, just over 13,000 bags. So let's look at our options for opening a fishery. Okay, so let's say we have 5 harvesters, 10 harvesters, or 20 harvesters. And each one of those can either harvest 5, 10, 15, or 20 bags per day. All right, so I wanted to know how many harvest days would be available for each of those scenarios. So if we take the top one, that's 5 bags a day, right? So if you have 5 harvesters at 5 bags a day, you can harvest for over 2 years, right? Which is great, but that's not much of an income. And this graph is very simplistic. It doesn't take into account the fact that oysters are going to be growing during that time. This is just taking into account what we have right now. So if we go to 10 harvesters at 10 bags per day, they can work for 6 months. Okay, well, that's not great. If you let 20 harvesters in there at 20 bags per day, which is the legal limit for the rest of Florida, you've got 7 weeks before all of those oysters are gone and you're back down to that 300 bags an acre threshold, which cannot sustain a fishery. So again, this is a very simplistic approach, but what it illustrates is not that this is what FWC should do. It illustrates that the bay is vulnerable and we really need to be careful about how the fishery is managed when it opens. Because if we're not careful about it, we could end up right back at square one again. Okay, so I'm going to switch gears a little bit now. Oh, wait. Yes, I'm going to switch gears and I'm going to talk about our restoration experiments just very briefly before I hand it over to Devin. So we have 2 restoration experiments out in the bay. One we put down in 2021 using lime rock, large lime rock, small lime rock, and shell. And I've shown the results of this experiment a few times now, so I decided not to show it again. But what we found is that the larger lime rock material actually supports multiple generations of oysters, and it does significantly better than the smaller lime rock and the shell. So in deciding to put down the 2023 experiment, we used the information from that experiment, and we used lime rock again, same size lime rock, 5 to 7 inches. And we also used some concrete that was available, because we keep hearing, concrete is free. Well, it's not technically free because you have to crush it and clean it, but it's certainly readily available. You don't have to mine it. And it's also a waste product, especially with a lot of the infrastructure work that's being done these days. So let's look at concrete. Let's see how it does. So we use concrete, we use that lime rock, about the same size. And then because shell is kind of the gold standard for reshelling and restoration, we wanted to see if putting a layer of shell on top of these stable materials would actually help the oysters to come up and to settle and grow. So we have those 4 treatments. We put it at cap point between 2 areas that have been restored, and there were actually some oysters there. And so, like I said, we put those out in spring 2023. We had the oystermen help us put the materials out. The reefs were 38 centimeters tall, which is it's about 15 inches. And they were 15 meters by 8 meters. So they're quite small, not as big as the ones that FWC are doing right now. So anyway, lots of little bars on here, but what it shows is our sampling. Now these are tongable, mind. These reefs were sampled using tongs. So we hear a lot about these giant rocks that are being used and how they're not harvestable, but they actually are. It's hard, but it can be done. And so in fall 2023, you can see the height of the oysters is quite small. They've only been out for 6 months, but you can see some of them are starting to creep into that larger seed, smaller market size. So this is encouraging, and we're not seeing a lot of difference between the different materials. So as we move into spring 2024, this is our most recent data. We're not seeing a whole lot of difference between the materials. The concrete is doing equally well. And in fact, our most recent data, which isn't available yet, is showing that it's the concrete may be doing a tiny bit better. And there may be an effect of the shell on the concrete. But all in all, it's showing that the materials are working. We're getting market-sized oysters, and that the concrete and the lime rock are doing equally well. So concrete is actually an alternative option that might be more economically viable and more environmentally friendly, since you don't have to take it out of the mines. So the fact that it says here concrete performs significantly better, that's our most recent data. It's not reflected in this one, but there didn't seem to be much of an increase with using the shell. And initially the lime rock was performing poorer, and part of the reason for that was because some of the material that we got was a little bit bigger than we had wanted. So those are our data, our sort of most recent data from our restoration experiment, and we're hopeful that it will continue to do well. And I think with that was my last slide as my summary, which I've just talked about. So I think I'm going to hand it over to Devin at this point to talk about the FWC restoration survey project. Sorry.
Yeah, thanks, Sandra. Anita, I think you need to hand over the sharing baton back over.
Will do. Just takes me a second.
No problem.
Should be good to go.
Yep. Let's see, share that, then do that.
That's not Apalachicola Bay.
No, we don't want our water that blue. We don't have the nutrients we need.
Or deep. Okay. All good?
Should be good to go. I can see your screen.
Perfect. I got new monitors all over the place, so I'm looking this way. I wanted to make sure the PowerPoint was in the right position and everything. But good afternoon, everyone. My name is Devin Resko. I work for Florida Fish and Wildlife Conservation Commission, or FWC. I'm in the Division of Marine Fisheries Management, and hopefully this is the only typo throughout this PowerPoint, but I am no longer the Fishery Disaster Relief Program Coordinator, so I do need to edit that title slide. I am the Biological Administrator in the Analysis and Rulemaking session, specifically with an emphasis on Florida oysters. And so today I'll be talking about one of the facets of oyster management I work on here in the state of Florida, and that is restoration in Apalachicola Bay. So just to provide a frame of reference, Apalachicola Bay is not only well known for oysters in the region, but the nation and the world. My family is from Kansas, and that's about as far away from the ocean as you can get, but they know what an Apalachicola Bay oyster is. And historically, about 90% of the source of Florida's oysters came from this one bay. However, there has been a significant change in the abundance of those oyster populations. Historic surveys show that the bay had more than 10,000 acres of habitat that would support an oyster population. But more recently, that has seen a sharp decline. In 2001, we saw about 2,000 acres, and that is marked in the green in that figure that you see on the slide. And then a few years ago, some additional mapping showed about 500 acres, which is in the orange areas, mainly focused around the eastern and central eastern portions of the bay. So overall, there's been a sharp decline here in Appalachia, but I think to provide kind of a global perspective, Appalachia is not alone in this sharp decline. There's really been about an 85% decline of oyster reefs throughout the world. And in many of these bays that once had oysters, there's been more than a 99% drop in those populations, basically having those populations in those bays being functionally extinct. We even had a discussion FWC did with all the other Gulf states at a 2023 Gulf States Oyster Symposium. And the thread that ran through all 5 states is that they were seeing significant declines in their oyster populations off of their states' coastlines. So one main endeavor that FWC has undertaken to help reverse this is a partnership we have with NFWF, or the National Fish and Wildlife Foundation. Basically, it distills down to settlement funds from the BP oil spill. So we have just a hair over $20 million in this agreement between FWC and NFWF. And kind of highlighting this agreement, the locations that we focus on with this agreement are Apalachicola Bay and Swanee Sound, that Cedar Key, Big Bend area. But a majority of the funds of this $20 million agreement are earmarked for Apalachicola Bay. And it can really be distilled down to 3 main objectives. We want to do baseline data gathering and mapping to know where we are at time 0 of this agreement. We want to do large-scale oyster reef restoration dedicated only for Apalachicola Bay. And we want to develop and revise the oyster management in both Apalachicola Bay and Swanee Sound. Even though it is an agreement between FWC and NFWF, there are multiple partnerships that are providing a lot of valuable input. Some of those icons are marked over to the right, but it's also important to stress the participation of that group on the bottom there, which are your local stakeholders, those whose livelihoods depend on this oyster fishery being sustainable. Those folks should have a seat at the decision-making table for all applicable processes. And my role as being the PI for this agreement is to make sure that we do hear from stakeholders and get their input every step of the way. So I'm going to just briefly touch over all 3 of these objectives throughout this presentation, with the bulk of it being on the restoration, that objective number 2. So our baseline gathering of data for both of these areas, and really I'm going to be focusing on just Apalachicola Bay for the rest of this presentation. But a lot of the data gathering is done by FWC's research branch, the Fish and Wildlife Research Institute, or FWRI. We have a field office tucked away in East Point. So they are the primary the staffers that are gathering a lot of this data. So we really break the bay into 3 different areas where we take a lot of data gathering. We have a lot of monitoring stations, and this really helps us to be able to break down the different sections of Apalachicola Bay. So some of our monitoring protocols, like Sandra mentioned, we primarily use in-water diving. That is actually me. They get me out of the office every now and then and let me get into the water. So divers go off the vessel. That is about what it looks like on a good day, where we collect material that are on the bottom, bring it back up, and we take a lot of data on the sample weight, the number and size of live oysters, the number of recently dead oysters, and also the different types of oyster predators that we are seeing throughout our samples. So it's really important to collect a lot of this information to really understand where we are prior to large-scale restoration. FWRI also collects water quality data just to get a kind of the full ecological perspective of what we're seeing in the bay. We also did a lot of mapping. It's important to understand the amount and locations of hard substrate. That really helps to inform our restoration efforts. So we had a contract with the University of New Hampshire. They perform a lot of oyster habitat mapping really throughout the nation. So for Appalachia, they brought their very sophisticated and high-tech vessel down here all the way into Florida from New Hampshire, collect a lot of data, 3D mapping, bottom profiling, and we also had individuals who were tonging and really kind of poking around the bottom to make sure that the data we were seeing in the mapping was reflective of what we were seeing with some of this ground truth tonging. And one major output that we did receive from this mapping effort is this image that you see here. Overall, there's over 15,000 acres that were mapped through these efforts. And this was kind of the foundational bit of data that we utilized for our restoration efforts that we completed this year in 2024 that I'll highlight here in a little bit. But we did have this data. We also had, again, this ground truth tonging data and kind of poking around with a PVC pole to understand the nature of the hard bottom, so or lack thereof. The yellow really shows that this is hard bottom or sand area. Brown is mud. And then the green areas focused up kind of near where the East Point and the Ainer lab is. Those green areas showed that there were current oyster populations. So these are all different sources of data that were really helpful because this ground truth tonging data is very reflective in this image that I just showed previously on the habitat that historically supported oysters versus where we are seeing oysters today. So all in all this mapping data really provides FWC with a good starting point to begin our restoration efforts with this NIFWIF agreement that we have. So kind of reiterating what I just talked about, some of the recent mapping showed that we had approximately 2,000 acres of potential oyster habitat that could support an oyster population. But overall, most of it is degraded and it doesn't really support spat settlement. Some researchers have said when they're out there diving, given clear conditions, it kind of looks like a tabletop. It's just flat and bare. There's no habitat for these oyster spat, these baby oyster babies to settle on. But something that I do reiterate throughout the presentation is that the east and central sides of the bay are kind of the main areas that are currently supporting what oysters are out there right now, and they likely represent the core of the oyster population, reflective of the entire bay. So this is just another image that showcases these efforts. There we go. Okay. Again, this mapping effort that we did have was very beneficial to help provide us the locations of where restoration could be done. Last fiscal year, we did receive $10 million state allocation from Governor DeSantis' budget that was exclusively for oyster reef restoration in Apalachicola Bay. So we were able to utilize a good chunk of funding that we were not expecting, but we could certainly use. So utilizing that $10 million, we determined best use of it would be to fund a restoration pilot study. And it really boils down to some of the past restoration operations in the bay didn't really perform as well as expected on an ecological standpoint. And that kind of leads to a large number of unknowns that are still present on what's the best way to restore the bay for oyster recruitment, settlement, and a thriving oyster population. So with this restoration pilot study that Marine Fisheries was going to manage, FWRI, our research branch, would conduct the sampling and the monitoring oversight. FSU, like Sandra just mentioned, also performing a lot of studies that certainly complement our own, just provide additional data. And utilizing our studies, utilizing FSU studies, it just provides more data on what worked and what didn't work to move forward in the future for large scale restoration. So we looked back at this map that we had from the University of New Hampshire and decided this was kind of the sandbox that we were going to play within, because again, central and eastern sides of the bay had the most oysters and really provided the most bang for our buck for this restoration pilot study. So kind of focusing in on this area represented in the red square, we had a lot of data coming in from different areas, and we wanted to utilize all of them and maximize them to make sure we had the most information moving forward. So this area right here in the upper left is just your natural hard bottom. You want to make sure that you are putting it on hard bottom, not in mud. So we utilized this. We had side scan data, which you see on the upper right, just to help reiterate the substrate profiling to make sure that it was indeed hard substrate. We looked at different types of bathymetry data. We wanted to make sure that we put it in a good depth that was not too low, not too high, really wanted to hit it in the middle. And then this area right here, it may be kind of difficult to see, but the areas that are crosshatched, they may almost look a little bit of gray. Those are areas where there are currently oysters. We want to make sure that we're not dumping rock on top of oysters, but we want to put them next to oysters to help support and supplement that oyster recruitment. And then the yellow area, yes.
We're seeing still your last slide that says pilot study, $10 million utilizing. Are you showing a map right now?
I am. So I had that issue with
now we're seeing it.
Yeah, I just bounced to a new tab and then it suddenly updated.
Okay, great.
But yeah, this final map or this final image in the lower right just provided, provided additional confirmation of hard bottom. So all this information we utilized. We also had discussions with local stakeholders and other scientific subject matter experts from other state agencies and universities, just to make sure we have the most information moving forward. And utilizing all of those sources of data, we came to these areas marked in red. So they do look quite small, but they're 1 square acre in size. And they really hit all 5 of these characteristics that I kind of hinted on just previously. Wanted to make sure we had hard bottom, good water flow, they were nearby current oysters, they weren't a navigational hazard, and they were also easily, these locations were easily navigable for our contractor to get in, deploy the material, and get out. And so all of these locations here really checked all 5 of these boxes. So in regards to the material that we utilized, or I guess first I'll talk a little bit more about the specs of the restoration pilot study. So we were testing 2 different reef heights, 1 foot and 2 foot. Oyster reef relief is very important for successful oyster recruitment. Some of the past restoration work that was done in the bay was in terms of inches, and we wanted to do in terms of feet to really kind of build those oyster reefs back up from the bottom. We also had some general restoration areas, which I'll hit on here in a few slides, but transitioning to the material type, we had a lot of discussions with stakeholders, with prospective contractors, and we determined we would use Kentucky blue limestone. That's been used previously in the bay, and it has shown some pretty positive results. So the material size is a little bit larger than material that's been used in the past. I typically have samples of both small rock and large rock, but I've since moved into a new office. Those have not made it over yet, so apologies. But typically we've been using almost pebble-sized rock. but this is 4 to 8 inches. So I kind of said some are going to be smaller, some are going to be larger, but it's about the size of a soda can or a red Solo cup, something about that size. It's a little bit larger. We were looking at using even larger rock. It was cost prohibitive, and it was opposed by stakeholders. They wanted smaller rock than what we decided to use. So I think both parties could live with the decision. No one was super happy about it, but like Sandra's mentioned, it is tongable. You may get more of a workout tonging it, but it is possible. It's also going to hopefully stay in, with ripping water currents. If there's any storm activity, we want to make sure that we are deploying material in such a way that we are providing long-term benefit and long-term resilience for these oyster reefs. So overall, we got about 75 acres of degraded oyster habitat. So I think this is primarily just an overview of what I talked about with the pilot study. So overall, you can kind of start at the middle of the slide and work down. We did hire a site observer to be on the water as much as mentally and physically possible to really observe the contractor to make sure that material is going in the right locations and at the right specifications. We exhausted all $10 million of the state allocation. I think we had about 14,000 that we reverted, so we spent 99.9% of the budget, and then a lot of the work that FSU is doing is just really increasing the scientific scope of what we know in Apalachicola Bay. So this area right here, this just provides a little bit more detail. So the area marked in red, that is our pilot study. That is half of them at 1 foot, half of them at 2 foot, about 1 square acre in size. We did have some leftover funding from this $10 million after we paid for the restoration pilot study, these 24 1-acre reefs. So we did provide FSU with 4 1-acre reefs as well at 1 foot relief, just to help them conduct additional studies, because it is, again, for the long-term benefit of everyone who is interested and concerned in the bay. And then we talked to some stakeholders as well and said we have some leftover funding where we can just do general restoration, just 6 inches worth of rock going out into the bay. No real scientific studies being utilized, or these reefs are not being utilized for scientific studies per se. It's just getting material out there for the benefit of the oysters. I think pretty much everyone that I talked to, all the local stakeholders, they said Cat Point or East Hole. So these are the 2 areas that we did this kind of general restoration for. Cat Point up north, and then the East Hole polygon down in the left, or sorry, down in the south bottom of this photo. So overall, all of these reefs, about 75 acres of material. These are some of the photos of the work. So if anyone has been driving around East Point or going over the bridge, seeing these barges deploying this material over the last summer, this is our work that was funded. And then as you can see if my mouse will come over. Yes, so over here you can see we have a few barges here. This is a good representation of the work that was done. So very large hopper barges. These larger ones over here came all the way down from Kentucky, down the Mississippi, through the intercoastal to Apalachicola. They were then, the material was then moved over to these smaller barges that you can see just over my right shoulder. And then those much smaller, they had much less draft. Those were actually pushed on, transitioning back to this photo on the left. Those were the barges that were moved on by tugs onto the areas and received restoration. So all in all, there were a few logistical hiccups with some of the waterways in Alabama. Fortunately, no storm activity near Franklin County that caused very large delays. So all in all, it was pretty good. We had some areas that were a little bit taller. If anyone heard in Appalachia, East Point around the 4th of July, we had some areas that did pose a navigational hazard. We were very quick with our contractors to get out and smooth that. Our site observer, even though the restoration work has been completed, our site observer continues to perform some mapping. When it's not blowing out, it has been pretty difficult to get out as of late, but he is continuing to do post-restoration mapping. We do find any areas that may be a little difficult to navigate if the winds are blowing and it's a winter low tide. We're certainly going to take those concerns seriously and take any corrective actions necessary. We have been seeing some pretty good spat settlement. I always, when showing these photos, just want to add a little bit of caution is that we have been seeing good spat settlement, but kind of transitioning to those seed, to those teenager oysters, that's been the difficulty. So I'm hoping with this relief and really building it up off of the bottom, we're able to overcome that hurdle, but that's just something that we'll see once we provide the right amount of soaking time for these rocks and our researchers are able to get out and take a look. So in regards to the management, why we're trying to increase the oyster populations through restoration, it's all for having a sustainable oyster fishery management reopen in Apalachicola Bay. We continue to gather public feedback and as well as continue to monitor and analyze the biological data that FWRI is gathering. One footnote that has been very clear is that some of the improvements we've been seeing in the bay are really only found where restoration has occurred. If restoration has not been performed in a certain part or location of the bay, we're not really seeing many oysters out there. So overall, the decisions on not only future restoration, but reopening of the bay and how that looks, what type of management scenarios are utilized and employed in that management, they'll be data informed and they will include public input. We also continue to not only increase our stakeholder engagement, and we will continue even to increase that even more come 2025, but we are leveraging the process of many external working groups, for instance, the Partnership for Resilient Apalachicola Bay, really just gathering all the input, what they like, what they don't like, getting direction internally within FWC, and really making sure that we employ the best management scenario that is beneficial for both oysters and oyster harvesters in the long term. Well, I think one thing everyone can agree on is that the current amount of funding that is available is not everything we need. We need more. So we do continue to actively research and lobby for additional funding opportunities. So in conclusion, over everything I've spoken about throughout this presentation, the NIFWIP agreement that we do have, about $20 million in total, really distills down to preliminary data gathering and analyses, restoration efforts, and stakeholder-informed oyster management for both Apalachicola Bay and Suwannee Sound, Big Bend area. But we did receive an additional $10 million from the state for reef restoration only for Apalachicola Bay. And that restoration did fund that pilot study, providing some reefs for FSU and some of that general blanket restoration, which was completed last month. And that work, as well as FSU's work, continue to help inform FWC for our future restoration. We have money for future restorations. The stuff that we just completed that I talked about, that was just the next phase. We do have continual funding ready, and once the timelines all align ecologically, as well as fiscally and programmatically, we will certainly continue our restoration efforts. And I always like to end my presentations by just stating that I believe successful Apalachicola Bay oyster restoration be possible through the culmination of the work from our management entities, university researchers, and the local stakeholders. So there is my contact information. Hopefully my phone is working in my new office soon, so maybe email is best. But at that point, I'll hand it back over to Anita to help facilitate any questions for Sandra or I.
Great. Thank you so much, Sandra and Devin. If you want to raise your hand, I've taken everybody off mute, but maybe raising your hand, that'll give you a chance. David Adlerstein. You should be able to unmute yourself. Okay. Let's see if we have any other
Unmute. Can
questions.
you
How
hear me
about,
now?
yes, I can.
Okay, I'm sorry. All right. My question is the Kentucky blue limestone the stuff that's being piled in Gulf County by Couch Aggregate, and then they're trucking it in from there?
So in regards to the Kentucky Blue that we utilized for that restoration study that was just completed, it did not touch any land once it left Kentucky. It was put on a barge, brought down the Mississippi, and then into the bay. So I'm not familiar with the work that you're referring to, but it is not related to any of the FWC restoration in the bay. No.
Okay, thank you.
And Nicole, you had a question. You should be able to unmute yourself. Hmm. Seems to be a delay. Feel free to type any questions into the chat box too.
You hear me now?
Yes.
Okay, it's Nicole and Mike. We were
Okay.
just wondering. So, first of all, that was a great presentation. I think we both learned a lot from that. Is there any idea on why it looks like the east side of the bay is performing better than the west side of the bay?
Yeah, I mean the what's the word I'm looking for? The sort of conventional wisdom is that it's saltier, and the habitat is so degraded that back when dry bar was historically productive, dry bars in the west side. It was kind of at low tide, it would be like a string of pearls. It's been described, it was actually intertidal. And so those reefs were sort of periodically exposed. And that may have given the oysters some relief from predation, but that was a long time ago. It's a salty environment because most of the water that comes into the bay comes in through West Pass, and the habitat is completely degraded. But honestly, we're not quite sure. We just don't know. I mean, the materials that we put out did really well in the east. Same material, same monitoring, and they just struggle. They don't make it through that juvenile stage, which has been characteristic of all of these restoration efforts throughout the bay in the past, with a few exceptions. But so we think it might be related to the conditions and the associated predation, but that's just our best guess at the moment. It's not very satisfying, I'm afraid.
Okay. Anybody else have a question? While they're thinking about it, I have one. Devin, do you know, we talk about the $10 million and then the National Fish and Wildlife $20 million. Is there an idea when the pilot will sort of be at a stage we can start the other restoration? Do you have a feel for when that additional restoration will start taking place?
Yeah, so Apalachicola Bay is known for growing a quick oyster, but we still have to let them, soak 12 to 18 months to really get a good idea. But that doesn't mean we have to wait until we have all of the results from the pilot study to move forward. In kind of two ways. We can start the competitive solicitation. We are government, so we have plenty of hurdles that we have to overcome before we can actually get material in the water. So we can really start that competitive solicitation drafting and getting all of our ducks in a row internally. But also, we can certainly come up with, if we have funding ready to roll, we can certainly talk with our funding partners and come up with additional restoration, knowing that we have perhaps preliminary results from our restoration work. We have results from some of the work that FSU has done. That if we feel that we have a restoration blueprint ready to roll, we can certainly discuss that with our funding partners and move forward. So again, we have to have I'm thinking of 3 certain things aligned. We got to make sure that the oyster spat is ready, we have the budget, and we have the methods. And once all 3 align, I think we can really move forward. So even though it will take some time to get some really good black and white data off of that restoration pilot study that we just completed, I don't think we have to wait until we have the full results to move forward with the next phase of restoration.
Great. Okay. David, did you have another question?
My other question was, hypothetically, I think I know the answer, but if hypothetically you were appearing before the FWC and there was a request to open the bay earlier than projected, what would your answer be in terms of a recommendation?
So there are so many parts that go into saying yay or nay for that for the reopening of that bay. Basically, the process, as we see it, given that the bay is set to reopen in about 13 months, our timetable is upcoming in 2025. We have a lot of oyster-related items coming to the commission meeting. And so I think this is also beneficial to bring up, is come February, the February commission meeting in Tallahassee, we are going to be giving DMFM is going to be giving a presentation to the FWC commissioners about Florida oysters, the state of Florida oysters, really focusing in on the Big Bend and Apalachicola Bay, and even more probably focusing in on Apalachicola Bay. So that's in February. Come May, we'll also bring items regarding Apalachicola Bay management. And then in the September, August, the fall commission meeting, we'll have even more discussions on the management of those areas. I'm not sure where the locations are for the May and the August commission meetings. Again, February is in Tallahassee. But once I have those updates, I'll certainly provide those to all concerned individuals in Franklin County. I will say that when a rule is being decided upon by the FWC commissioners, and it is as high profile as Apalachicola Bay will be, they try and put it in the area. So while I can't say for certain, it will most likely be in the Panhandle. They are going to do everything they can to make sure that it is in an area that is easily accessible by concerned stakeholders.
Thank you.
Okay, I'm not seeing any other hands. And I just wanted to thank you both, Dr. Brooke and Devin. Thank you so much. It's great to get a comprehensive update, and we'll keep everybody posted as well as we can. But thank you so much, and we appreciate everybody joining us.
You're welcome, Anita. Anytime.
Thank you.
Okay. Thanks,
Bye.
everyone.